Hey, I'm Sam. Welcome back to Lytei, where we empower light ideas. Have you ever seen something that's illuminated, but you weren't quite sure where the light source was? There are two parts to an effective backlit solution. The first is the surface itself, while the second is the geometry and the relationship of the surface to the luminaires that surround it. You know, something like this. Did you notice what the difference was? Aside from the variety of applications, it was the diffuser. In backlighting solutions, typically the illuminated surface is a diffuser, but to make it look good, you'll need a lighting detail too. This is a good place to check in with a lighting designer. Meet Chip Isreal from the Lighting Design Alliance. What's going on, Chip? It's good to see you.
I'm glad to be here.
Walk me through what you would consider when backlighting something.
What we really like to do is to use backlighting as a design tool and to really reinforce key objects within the space or to reinforce graphic wayfinding. I think there's three main properties. Number one is the amount of space. That's the depth between the glass and the back wall. The next would be the material itself, whether it's glass, plastic, resin, stone. And then finally, what are the light sources that you want to do? Typically, those would all be LEDs today. So I'll kind of break those down. Of course, we have to start with the material.
Transparent, translucent, and opaque, or TTO, are three terms that are often used interchangeably in design. But when it comes to backlighting, they must not be confused at all.
Best thing is to get a sample so you can actually look at it, hold it up to light. The thicker it is, the more transmission gets lost of it, and it also has to do with the transmission properties itself.
How much light passes through it versus how much is blocked is a variable ratio referred to as transmissivity, or how much light is transmitted through the material. Think of this like the opacity slider in Photoshop from 0 to 100, either letting no light through or all of the light through. Translucent is defined as an object that allows some light to pass through, but not detailed shapes.
A deep space gives us a lot of opportunities. In the good old days, maybe we would put fluorescent lamps on the back surface and basically wash this translucent surface.
Transparent is defined as a surface allowing light to pass through so that objects can be distinctly seen.
The other option that you have is actually to floodlight a surface. If you have a back wall, perhaps a drywall, we could put floodlights and wash the drywall wall, and then the luminous panel will basically glow. And that works well if you have a combination of translucent and transparent glass because you don't see any of the light sources. That takes a lot of space, probably about a foot to maybe even 18 inches in minimum.
Last but not least, opaque is defined as something that does not allow light through at all. Thus, you would never be able to tell what object was behind it. Something that is opaque will often have 0% transmissivity, while something that's transparent will be 100% transmissive. This makes a translucent surface ideal for backlighting applications. Here's where it gets interesting though. How about a piece of paper? Or a piece of paper with a bunch of holes poked in it. When the surface is treated with a uniform coating, like a film or a paint, the end result is something that is consistent. However, if the surface is etched or beveled, it can remain inconsistent.
As the space starts to get closer together, you have to have some other alternatives, and that's where LEDs have really helped out. For example, if you have about 6 inches, maybe use a dot matrix type of solution. As the spaces get tighter and tighter, maybe now down to 1 to 2 inches, now you probably have to do some type of light panel. That way you get rid of seeing hot spots. Bottom line is, it's a lighting tool, and you have to figure out why and where you're using it. So, for example, your entire ceiling could be a luminous plane, which works great. But one caution is, it kind of feels like a cloudy day. So you have to be careful with that because for thousands of years, we've all learned to see with some shadows, and that's what makes it feel natural to us. The other caution you have is if it's bright side panels, that can create a little bit of an unbalance in the space, especially if you use color. Last thing you want to do is to have a big green wall and all your food to turn green in a restaurant.
When it comes to controlling that, how do you incorporate dimming into your design?
What you really have to understand is that the eye sees different than powers. 10% power is about 35% brightness, and that's really bright, especially in a dark environment. 1% may be closer to 10% visual brightness. We need a lot of pixels or a lot of linear light so we don't get hot spots, but that means we're almost overlighting the surfaces. So we found out a combination of dimmers or even dimmers with some neutral density filter is a way to tone it down to get the appropriate brightness levels.
Well, let's take a look at a couple examples.
Great. Seeing is believing. I think what you really need to know is when and where you're using these techniques and what the ambient light level is. For example, if you're lighting the crown of a building, obviously it could be off during the daytime, but you want it to be bright and vibrant at nighttime, and maybe even as a curfew, later at night, it could dim down. Opposite to that is if you're doing an accent piece inside, well, you may actually need it to be somewhat brighter during the daytime to compete with the ambient sunlight. And then as the sun goes down, you might actually decrease the light level. So kind of an inverse of that. So you really have to understand about what brightness you want it to be. And that's where controls are really important. Remember, probably the most expensive cost is the art glass itself. That could be several hundreds of dollars per square foot. And the simple rule of thumb is the deeper the space, probably the fewer number of sources you can use. As you've seen in examples, the closer the light is to the glass, the more of a hotspot type of effect. At the end of the day, we want more of a uniform effect. But remember, the deeper it is, now you're losing usable real estate. And the cost of the building probably far outweighs the cost of the LEDs themselves. LEDs last forever. You don't need any maintenance. No, it's a great point. In a lot of these applications, we may remote the driver away from the LED so they last a little bit longer and operate under a little bit cooler temperature. But the most important thing is we're going to have to get into this cavity, maybe sometimes to clean it, but more importantly to access the light.
Well, there's no doubt that maintenance is something that's certainly important. Where do you see backlit applications most often?
I would probably say as an architectural accent versus an entire lighting solution. So this could be, for example, in the front of a registration desk or a hostess desk. It might be the back wall of a bar. It might be overhead, for example, as an accent piece. A lot of times it's built into the architecture. So think of now columns becoming sconces, the crowns of buildings becoming lanterns. They're all opportunities to turn the architecture into lighting fixtures.
Do you have any final thoughts on backlighting solutions?
I think it's a great opportunity. Two concerns. Number one, mock it up. That's going to be your best opportunity to really test and to make sure it works. And then the second one is draw a detail of it. And it's okay to have the detail in your lighting section, but make sure that detail is in the interiors and the architectural sections. Because unfortunately, the people building the millwork never look at the lighting drawings. So get it in everybody's drawings and there's a better chance of success.
That's a quick snippet on what it means to backlight something and what the difference is between translucent, transparent, and opaque materials. But the bottom line is, take into account the material, the luminaire, and the depth. I mean, after all, who would have thought you could take architecture and light and combine them together?
What a concept.
Indeed it is. And I tell you what, if you like what you saw and you want to learn more about lighting, do me a favor. Click that button right on Chip's face and subscribe to Lytei. Or if you have questions, shoot us an email at that address right there. And until then, see ya.